Okay. I would like to remind you again. For this motor control, you should learn 3 controllers. Okay. One pole placement controller been complete. I just able to download 2 parts for the video only. If you look at the YouTube, for the pole placement controller, I just upload 2 parts. It's not finished yet. Because I've been hospitalized and because not well. So I try to finish to complete the videos. Okay. And then the second controller is today, which is observer controller. So we will complete within these 2 hours. And then the final controller is an integral controller. The integral controller is your assignment question. Your assignment question is based on integral controller. But don't worry, I'll let you know that it will not going out for your final exam, integral. Integral only for your assignment only. Okay? For the final exam, we'll cover 2 controllers. Pole placement and observer. Okay, please take note about this. Integral only covered for your assignment. For your final exam, we'll cover 2 controllers, pole placement and also observer controller. Okay, can anyone please shut the door? Okay, I believe for the pole placement controller, you should know how to design it because it's already in lab number 2. So you should understand the process because you need to complete lab number 2. So there you must have the knowledge of the pole placement controller in order to complete lab number 2. So let's say if the question been asked in the final exam for the pole placement controller and you can answer it, so we know that you did not do lab number 2 by your own self. So that's we can conclude lah, kan? If you do it by your own self, then I believe you can do any question regarding the final exam about pole placement controller. Is it logic? Is it make sense, kan? Okay, make sense lah. Okay, so today I will cover for the observer controller. Why you learn observer controller? Why you learn? I give you a situation. Can you imagine a rocket built by who? A space rocket built by SpaceX. As an example, yeah. What is the CEO of the SpaceX? Elon Musk, kan? Okay. So you have a rocket and then you want to send the rocket to the space. Okay? Can you imagine the fire, the fire going out from the rocket? What is the temperature? 2,000 temperatures, kan? 1,000 degrees Celsius. Because too hot, kan? Although if you look at, if you want to see the rocket launching, you need to have very far radius because it's very too hot. Okay. So, can you measure the exact temperature? Can you measure the exactly temperature of the fire? Can you measure it? What do you use? What do you use to measure temperature? Huh? Apa? Thermometer, kan? Okay. You use any instrument lah. You use any instrument to measure the temperature, kan? But do you think the instrument can withstand with the thousands? It will be broken, it will be damaged, is it? Okay. So that's why we don't know what is the exactly temperature from the rocket. So that's why in control system, you need to do estimation. So we can estimate what is the correct temperature from the fire. We just estimate. So that's why when you say that, oh, the volcano, the temperature of the volcano erupt is about 10,000 Fahrenheit or 10,000 degrees. Do you think people will go there to put the thermometer? And then, no, everything is about estimation. So, that's why for today, you learn how to design a controller to estimate a system performance because of that situation. Do you clear? Okay. If you refer back to the pole placement controller, okay, we talk right now is about pole placement controller. You know that x dot equal to ax plus bu, and then you replace with the negative k x, and then x dot ax plus, you just put it plus b negative kx a minus b k x dot. So this is for the pole placement controller. This is pole placement controller. So for the pole placement controller, it's very straightforward. When I talk about what we want to measure, according to the rocket example, we want to measure the temperature. Yeah. So the x normally represent if you refer to the lab number 2, the x, it will be angular displacement and also cut displacement. This one you can measure directly. Yeah, you can measure directly. What is the angle? You can see directly the pendulum angle, and then the cut, how far it displaces and so on. So it means that it's a direct measurement. So that's why for everything, any system that we can direct measure the x, which is state variable, such as angular displacement, cut displacement, we can use pole placement controller, no problem. Okay, whatever system that we cannot directly measure the x, such as the rocket, temperature and so on. This is the temperature. Temperature, you cannot direct measure. So you can use observer controller. Okay, so that's why you learn pole placement controller. So that's why you learn observer controller. Is it clear what's our objective for today? Why you learn observer controller? Yes, okay.